Hi guys, welcome back to my YouTube channel. It's Mwalimu R Gigi, your favorite teacher in the 254. So today we want the height of collimation method. That is 7. So for height of collimation method, we remember the booking. The booking, we introduce the height of instrument, and then the reduced level, and lastly we have the remarks. So at point A, the remarks was the benchmark of 100. So we want to reduce these levels using the height of instrument, or the height of instrument, or height of collimation. The height of collimation method. So the first step is finding the reduced level. So we have to mark we have to name, or rather to give names to our points. So this is at point A, at point B, at point C, then we have at change point 1, then we have at change point 2, then we have at point D, then we have change point 3, then we have at E, then lastly we have at F. So what was our formula for finding reduced level? Is equals to height of instrument minus backside or foresight or intermediate side. So if you have a backside or a foresight or intermediate side, you subtract it from the height of instrument. So here we have 3 heights of instrument, because we have changed our instrument 3 heights. So we had 1, then we changed, then we changed, then we changed. So we have 4, in fact, 4 height of instrument. So the first instrument was placed here. We took the first reading, intermediate side, and the last reading. Then we changed our instrument. We got the first reading and the last reading. Then we also changed our instrument to get the first reading, intermediate reading, and the last reading. Then we changed again the instrument to find the first reading and intermediate and the last reading. So the first step, we know the formula is reduced level is equals to height of instrument minus backside, foresight or intermediate side. So at point A, we have a reduced level of 100. So if we have a reduced level, we have the reduced level as 100. So we want to get the height of instrument at that point. We want to get the height of instrument. So we have a backside, and we have a reducing, and we have the reduced level. So what is the height of instrument? So we'll make the height of instrument the subject of the formula, of this formula. So the reduced level will be reduced, the height of instrument will be reduced level plus backside. So our reduced level is 100 plus backside, which is 3.10. So 100 plus 3.10, which is 103.1. So the height of instrument 103.1. So 103.1, 103.1, 103.1, 103.1, 103.1. So the foresight. So this is the last reading. So when the instrument was at height of collimation of 103.1, it took the last reading of 3.96. So let us find the reduced levels. So at point A, the reduced level is 100. At point B, the reduced level is height of collimation minus back side or foresight or intermediate side. So it is 103.1 minus 2.56. So 103.1 minus 2.56, which is 100.54. So the reduced level at point B is 100.54. At point C, we have the height of instrument and we have the height of instrument and we have an intermediate side. So the reduced level at point C, it is 100.1 minus 1.07. So it is 103.1 minus 1.0. So it is the reduced level is 102.03. So it is 102.03. At change point 1, we want to get the reduced level. Then we use that reduced level to get the height of instrument. So at change point 1A, we want to get the reduced level. So we have the height of instrument was 103.1, and then we have a foresight of 3.96. So it is 103.1 minus 3.96. So 103.1 minus 3.96. So it is 99.14. 99.14. So that is the reduced level. And B, at change point B, we want to get the height of collimation, because at change point we have a foresight and we have a backside. So we want to get the height of collimation. We have the reduced level and we have a backside. We have the reduced level and we have a backside. So what is the height of collimation? It is reduced level plus backside. So reduced level plus backside. So height of instrument is reduced level plus backside. So at change point 1 B, we will have 99.14 plus 1.92. So it is 99.14 plus 1.92, which is 101.06. So the height of instrument at this point is 101.06. So we use this. We found the backside and the foresight. So at change point 2 A, we have to get the reduced level. We have the height of instrument and we have a foresight. So it is 101.06 minus foresight, which is 0.67. So 67, which is 100.39. So the reduced level at change point 2 is 100.39. So at this point we also have the backside and we have the reduced level. So we want to get the height of collimation. We had to get the height of collimation at change point 2B. To get the height of collimation, we have to find the height of instrument or the height of collimation. What has to use the height of collimation? So to get the height of collimation, we say that it is reduced level plus backside. So reduced level is 100.39 plus backside, which is 1.2. 0. So plus 1.20. 1.2, yeah, 1.20, which is 101. So our height of instrument is 101.5. 101.59. So 101.59. So at D we have the height of instrument 101.59, and we have that D we have the height of instrument, and we have the intermediate side. So it is minus the intermediate side, which is 4.24. So 101.59 minus 4.24, which is 97.35. So it is 97.35. At change point 3A, we want to get the reduced level. So we have the height of instrument 101.59, and we have the foresight. So it is 1.87. So to get the height, to get the reduced level at that point, it is 101.59 minus 1.87. It is 99.72. 99.72. Then we have a back side of 0.02. So at change point 3B, we have a back side and we have the reduced level. So 99.72 plus, from this, height of collimation is reduced level plus backside. So plus 0.02. So plus 0.02, which is 99.74. So that is the height of instrument is 99.74. 99.74. So at point E, we have the height of instrument and we have an intermediate side. So it is height of instrument minus intermediate side of 3.03. So 99.74 minus 3.03, which is 96.71. 96.71. And at point F, then lastly we have the height of instrument, and we so at point F we have the height of instrument 99.74, and we have a foresight of 1.7 1.41. So 99.74, 99.74 minus 1.1, 1.41. So it is 98.33. 98.33. So we want to check if we have done the correct thing. So we want to check. We want to do the arithmetic. So we want to get the we want to know the arithmetic check. So the arithmetic check for height of instrument is the sum of backside minus the sum of foresight should be equal to the last reduced level minus the first reduced level. So the sum of backside is 6.24, and the sum of foresight is 7.91. So, and the last reduced reading is 98.33, and and minus 100. So 6.24 minus 7.91 is negative 1.67, and then 98.33 minus 100 is equals to negative 1.67. So we have reduced our levels correctly for this data. So that is the methods of reducing. That is the methods of reducing levels. We use the height of collimation method, and we also have the rise and fall method. So that is all for today. We'll have more. We want to see if the backside, if the benchmark is given at maybe at point D, maybe the benchmark is given at point D or at change point or at F. So we will be looking at that in the next video. So stay tuned and subscribe to my YouTube channel. Sawa sawa? Okay.